I'm presenting it for the fifth International Conference on Applied Zoology. And my name is Dr. Shabnoor Iqbal. I'm teaching assistant in Department of Zoology, Government College University, Faisalabad. My study entitled Virtual Screening of some selected compounds of Artemisia absinthium to assess anti-inflammatory effect against human necrosis factor, cyclooxygenase 2 enzyme, and nuclear factor kappa B. Artemisia absinthium is very important medicinal species and formally described in medieval Europe as most important master against all devastation. And it is also very important traditional medicinal plant in Asia and used against very different ailments like gastrointestinal ailment to treat the herpes, anemia, insomnia, bladder diseases, and to reduce the wound inflammation and healing. It is important to discuss the molecular docking as virtual screening is based on the one of the technique of the molecular docking. Docking studies are actually computational techniques for the exploration of the possible binding modes of substrate to a given receptor or enzyme. In molecular docking, there are two types of interaction were studied: protein ligand interaction, protein protein interaction. In our study, we use the protein ligand interaction and ligands are structure that binds to binding site of the receptor, while the receptor contains the active site, uh, and the binding site of the set of the amino acid that physically interact with the ligands. The ligand and protein interaction based on the two theories that are the lock and key theory and loose fit theory. In the lock and key theory was proposed by the investigator. According to him, the lock is the enzyme and the key is the substrate. And just like that, only the correctly sized key fits into the hole of the keyhole of the lock. Just like that, the substrate of particular size attached to enzyme with same size and structure. In this diagram, you can see that the substrate structure is different, so it cannot bind with the binding site of the enzyme with different structure and shape. So the next, you can see that the binding site of the enzyme and substrate have the same shape and structure, so they can attach and make the product. Induced theory explains certain molecules bind with the enzyme but do not detect because enzyme sometimes distorted due to molecules or other some molecules are too small to induce the proper alignment and only proper substrate with is capable of inducing proper alignment with the active side of the enzyme. These are the some software of molecular docking that are Sanjeevani, Gold, Autodock, Temdoc, Hex protein docking, gram protein docking. In our study, we use Autodoc methodology. In the best study, we choose 14 compound of the Atmesia absinthium, and the compound was selected based on the previously reported study. This is a schematic view of our study, and that in the first step we select the ligands and receptor, and then we prepared in the software of the discovery visualizer, and in the Pyrex software we process the receptor ligand docking, and at the last we studied the binding interaction of the receptor and ligand. For the preparation of the receptor, we use the BioVia Discovery Studio, and for this we remove the in this software we remove the heteroatoms, bonded ligands, water molecules from the protein chains. Only protein with the particular chain and active site were saved in the form of PDB file, and this is the software of Discovery Studio Visualizer. In the Pyrex software, uh, we upload our desired targeted receptor and ligands, and you can see the software here. And the molecule side, we uploaded the ligands and receptor, and then we start the Vina wizard. And in the gray area, we get our 3D structure of the ligands and receptor, and then we run the Autodoc Vina and get our result of doxing score. This is the list of Artemisia absinthium compound, and they are actually downloaded from the PubChem and in the form of STF files, and and these are the listed their compound IDs. These are the 3D structure of the our targeted receptors, and they were downloaded from the protein data bank, and by using their PDB IDs results. In first result, you can see that the receptor ligand interaction of NF-kB with our targeted ligands or compound of the Artemisia xanthium, and you can see that the best result were obtained between the NF-kB and secretiole, and that give the best binding energy, or you can say binding affinity. And in the next, these are the binding traction of TNF alpha with our target ligands, and you can see that the secretiole give best docking score with TNF alpha, and out of the 14, almost all compound give the binding traction with TNF alpha. In the COX-2 and ligand interaction, we can see that the best result same given by the secretiole, and out of the 14 compounds, 13 give the binding affinities. Best result you can see that given by the secretiole. These are the 3D structure of the ligand binding interaction, and we use the uh, studio discovery studio visualizer to make these interaction, and we only visualize those structure that give the best or better binding affinities with COX-2, and these are the interacting residues of the COX-2 and the compounds, and residues are actually amino acid of at the active side, and where they from which they interact with the ligands. These are the 3D structure of 3D structure of the NFKB and the compounds. Uh, as you can see, the interacting residues, and these are the interacting structure of the NFKB with the molecule compounds, and that give the best binding affinities. And these are their interacting residues that are the minus that you already discussed. And these structure are basically we processed in the discovery studio visualizer, and in first step we upload our sectors, and then we define our ligand, after uploading the ligand and after the defining we get our interaction interacting structure that you can see, and then at the last we get labeled this interacting structure and results. Out of the 14 compound of the Artemisia xanthium, TNF exhibited binding affinities with all compounds, and best score were given by secretiole, and its docking score was minus zero point 0.7 kilocalories per mole. And out of the 14 compounds, OX2 was expressed good binding affinities with 13 and except myrcene, and my minimum binding energy was given by the secretiole, and that was a good binding affinity and docking score. And NFKB also give good binding affinities with the secretiole, and at the last conclusion, the virtual molecule screening was helped to reveal absentia. Artemisia absinthium has binding affinities, has anti-inflammatory effect, improve phytoconstituents, and among 14 compounds, Kriegel was found most effective anti-inflammatory agent owing to good binding affinities with TNF alpha, COX-2, and NFKB, and that might use in future study to elaborate their possible anti-inflammatory pathway. Study also concluded that the COX-2 and TNF alpha are important receptors that are attributed to inflammation and might be down-regulated by Rior of that was the compound of the Artemisia absinthium. Thank you. Thank you very much for your attention.